Hey guys, so today we're going to be working on 3.4 converse proofs. So the first one says, if two lines form congruent adjacent angles, then the lines are perpendicular. So given is that two lines form congruent adjacent angles, we're going to prove the lines are perpendicular. In other words, L is perpendicular to M. Is what we're going to prove. So, whenever you're doing a proof, always your first step is start with the given. So draw my line here. So yes, first step is given. Two lines form congruent adjacent angles. And it's your given. Okay, second step. Look at my picture and I say, okay, if they're adjacent, and I notice they lie along the same line, those are called a linear pair. And if they're a linear pair, it means they add to 180. So I'm going to say angle 1 plus angle 2 equals 180. And how do I know that? Definition of a linear pair. And then I can look at this and I go, well, what's it mean to be congruent? Well, that means angle 1 equals angle 2 by definition of congruent. Well, if that's the case, if they're congruent, I can replace angle 2 with angle 1. So I can go angle 1 plus angle 1 equals 180 when I plug into that equation. So I plugged in, that's called substitution. Let's do some algebra now. Angle 1 plus angle 1, it's going to be 2 times measure of angle 1 equals 180. I combine like terms. CLT. And 6. I'm going, in order to get angle 1 by itself, I'm going to divide both sides by 2. So that gets me angle 1 equals 90. 6 divided by division. Now remember what we're trying to prove here. We're trying to prove that the lines are perpendicular. Well, if angle 1 forms a 90-degree angle, another perpendicular. So my last step here is L is perpendicular to M by definition of perpendicular. Because in order to be perpendicular, they form a 90-degree angle, which they do. So there's the first proof. Second proof, two adjacent angles form perpendicular lines, and the angles are complementary. So given two adjacent angles form perpendicular lines, we are going to prove angles are complementary. And to make this a little simpler for notation's sake, I'm going to label this A, B, C, and D. So I'm going, and then let's set up a proof. So whenever you start a proof, always your first step, given. So my first step is my given. So I'm going to write 1 here. 2 adjacent angles form perpendicular lines. How did I know that? It was given. Second step. Well, looking at my picture, what else do I see? I look at this and I go, I look at this and I see this angle 1 plus this angle 2 equals this whole angle. So I'm going to say that using my angle addition postulate. So I'm going to say angle ABD plus angle DBC equals angle ABC. Again, how do I know that? Angle addition postulate. Step 3. Well, if I can add those two to get the whole angle, and it says that those lines form perpendicular angles, what's it mean to be perpendicular? Well, that means angle ABC equals 90 by definition of perpendicular. So step 4 here, if angle ABC equals 90, I can plug that in for here. So I can go angle ABD plus angle DBC equals 90, because I plugged this 90, or this 90 here, and for ABC here. So that's by substitution. Well, if this angle plus this angle equals this whole thing, and these two, it says it adds up to 90, by definition complementary, that complementary means angles add up to 90, I can safely say that angles 1 and 2 are complementary. And how do I know that? Definition of what it means to be complementary, which means they add up to 90, which is what we just showed right there. Alright, this one. Let's draw our picture. If a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. So I have a parallel line here, another parallel line here, and it says a transversal that is perpendicular to the first one. So that means that, and I'm going to label these 1 and 2. We're going to prove that 2 is a 90-degree angle. I'm going to prove that this is a 90 degree. So given. It's just the same thing here. All this is my given. Perpendicular. That's what we're trying to prove. In this one, we're going to use a flow chart. So, oops. Let's see here. Let's see if I can do that again. Here we go. Yeah, this one we're going to use a flow chart. So, first step, I'm just going to label it as my picture. That's what I was given. After that, I see, well, if angle 1, I'm going to go ahead and write, based on my picture, that angle 1 is 90 degrees. And how do you know that? Definition being perpendicular. Now, looking at my picture again, I know that angle 1 is congruent to angle 2. Those are congruent. How do I know that? Because if those are parallel, which is what my picture says, which is what it says in my given, these are parallel, that means that corresponding angles are congruent. 1 and 2 are corresponding. So I'm going to say parallel lines implies corresponding angles are congruent. Okay? Now, if this is 90 and they're congruent, I can make another box right here and say that angle 2 must also be 90. I'm drawing my arrows here. How do I know that? By the transitive property, or substitution, what do you want to call it? And go substitution. Well, if angle 2 is 90, by definition, and let's label this, we'll call this L, we'll call this one M, and we'll call this one N. So I'm going to say N is also perpendicular to M. By definition, what makes it perpendicular? Because if it forms 90, it's perpendicular. If it's perpendicular, it forms 90. That's a biconditional statement, if and only if. So your flowchart might have looked a little differently, but that's what mine's going to look like. All right. Let's look at this one. If two lines are perpendicular to the same line, then then the two lines are parallel. So this is actually going to look quite a bit like the one we just did, except for it's in reverse. So whenever you start, always start with your given. Before that, we'll draw our picture. So two lines are perpendicular to the same line, then the two lines are parallel. So I'm going to draw another L and M. M. And it said these are perpendicular. I'm going to label it as 1 and 2. And I'm going to call this line N. Alright. So, first step, always is my given. So I'm just going to say picture. Then from there, well, what does my picture tell me? It tells me that those are perpendicular, which means they're 90. So I'm going to say angle 1 equals 90. By definition of perpendicular. And 3. Angle 2 is also 90. Again, by definition of perpendicular. So 4, well, if angle 1 equals 90, angle 2 equals 90, guess we know about angle 1 and 2. Angle 1 equals angle 2 by the transitive property. Well, if angle 1 equals angle 2, what's the relation between angle 1 and angle 2? Those are corresponding. Well, if that's the case, then we know that L is parallel to M because corresponding angles being congruent implies parallel lines. Therefore, we have shown that the two lines are parallel. Awesome. Oh, and yeah, does this have a counterexample? Let's think about this. L and M are perpendicular, but what would be a case where they would not be parallel? If you guys remember from earlier on in the notes, we talked about a situation where they're skew. What if L and M are on two different planes? So, in order to make this true, we'd have to state that they are coplanar. Because if they were not coplanar, they're on two different planes, they can be perpendicular, but they wouldn't be parallel. So that's how you make it work for all cases. Alright, last one here. One theorem about triangles is that the hypotenuse has to always be longer than this or this side. There is no case where in a triangle where the hypotenuse is shorter than either of the other two sides. That's a theorem. So we want to state that 4x minus 2, first of all, it has to be greater than 0 because the length of a side cannot be negative, so it has to be at least greater than 0. But it also has to be less than 18. So here, if you remember back from algebra, how we solve this, whenever you solve, you guys always got to look to add or subtract first. So we add 2. Instead of to both sides, we actually do it to everything here. So we go 2 is less than 4x, which is less than 20. Now what's happening to x? X would be multiplied. What's the opposite of multiplying? Dividing. So we divide both sides by 4. In this case, divide everything here by 4. So I get 1/2 is less than x, less than 5. So in other words, the range of values for x has to be between 1 and 5, or 1/2 and 5. So if I were to graph that, I would have 1/2 here. So here's 1, 2, 3, 4. Now it has to be greater than, so it's an open circle. It has to be less than, so it would look like this. All right, that's the converse properties for proving doing geometric proofs for 3.4. Let me know if you guys have any questions. Thanks.